Allee, morning. Can you hear me? Are you on mute?
Yes,
Oh, there we
I can
go.
hear you.
Okay, there we go. All right, so you got one more week of class before Christmas break, right?
Yes,
Okay. All right. You have any questions you want to go over?
not really.
No. And how's class going? Or how's your grade? Is it okay? What grade are you getting?
I'm getting like a B.
Yeah. All right. If you ever need homework help or study help or just preparing for the tests or quizzes, just let me know, right? And we'll.
Oh,
All right. But in the meantime, I have some practice questions we can go over. Let me share my screen. Share my screen. See where it is. All right. How do I do this again? Share. All right. Can you see the test?
yes.
All right. All right. Let's just practice. Let's keep practicing like we have been. All right. All right. Number one. Let's start off with number one. You can see it, right? All right. Let me blow it up a little bit. All right. Go ahead. The high school counselor.
A high school counselor conducted a study over 16 consecutive quarters to determine the number of students with part-time jobs. Each student in the 2014 graduating class is surveyed once per quarter for all 4 years of high school. The graph below shows the data for each quarter the survey was conducted. During which of the following periods is the increase in the number of students with part-time jobs largest?
Yep. 4 through 6, 7 through 10, 11 through 14 to 13 through 16. So four is right there, 4 through 6, that interval, 7 through 10, that and that. That's the second one, right? 11 through 14, 11 through 14. So which one does it look like?
Uh, 11 through 14.
11 through 14. 11 would be here. During which of the following periods is the increase in the number of students with part-time jobs the largest? During which of the following periods is the increase? Okay, 11 through 14. Let's see here. 11 would be here, right? 14 would be here. Okay, so at 11, it's about what? 58, so 58, 59, something like that. And then at 14, it's 62-ish, 62, 63.
Is it 7 through 10?
7 through
Because
10. 7 is right here. And then 10 is right here. Yeah, it looks like 7 through 10. 7 is at what? 20, 27, 28. And then 10 is at over 50, right? Yeah, 7 through 10. So B. 11 through, no, 13 through 16, 13, no, not really. 4 through 6, not really. Yeah, B, 1B. All right, that's B, 1. 2, where's 2? Eli saves money.
Eli saves money each month to buy a new computer. The total amount he has saved, T, can be calculated by the equation. T equals 83 plus 30, where M is the number of months since he started saving. What does the number 83 represent in the equation?
Yep. What is this amount right here on the beginning, at the beginning? Or it could be on the end here too. It could be 30M plus 83. That's the same thing. So what does the 83 represent?
The, the amount of money you started with?
Yeah, yep. A. Yep. M is the number of months. So he's saving $30 every month plus the original amount, 83. Yeah. 2A. 3. According to the Department of Agriculture, consuming 100 grams of banana provides 0.15 milligrams of zinc. Which of the following is the closest number of milligrams of zinc provided by 140 grams of banana? Okay, so how are we going to do that one? 100 grams of banana is this much zinc. How much is 140 grams of banana? How much zinc? How we do that one? Just set up a ratio here. So just go bananas over zinc. So 100 on top, 100 grams of banana is this much zinc, 0.15 milligrams. And then same thing on the other side, equals. Now we're going to keep the grams on top, 100 grams. So we want to put 140 on top, 140 grams. And then this will be X milligrams. Now just cross multiply. So those two times each other equal those two times each other. So 100X equals, what's 0.15 times 140? What's 15% of 140? 15, what's 15% of 40? That plus 15. What is that, like 20 something?
21.
Is it exactly 21?
Yes.
Okay, so and then now you just divide both sides by the 100. So that'll be 0.21, which is this one. So that question just set up a ratio. Okay. That was 3. All right, 4. When the equation.
When the equation y equals 5x plus p, where p is a constant, is graphed in the xy plane, the line passes through the point -2, 1. What is the value of p?
Yeah, so we're trying to solve for the p right there. So how do we do that one?
You plug in the point.
Yep, and then solve for p. Yep. Can you write on the screen? So plug in this x for right here, and plug in this y for right here, and then see what p turns out to be. Yep. Yep. Plus p. Yep. So what does p work out to be?
11.
Yeah, exactly. Yep. D. Add 10 to both sides, right? So
Yeah.
1 plus 10, that's 11. So let's check that. How do we check that? If we think it's 11, how would we check that?
You put 11. You replace p with 11.
And yeah, replace p with 11 and then see if left side equals right side. You know what I mean? Yeah, put on the left, put 1 right here. Put 1 right here. So does left side equal right side? Does this, is that the same thing on both sides?
Yes.
Yeah, so that's how we know we're right. So the 4D, that one's good. All right. That's one. That was just an algebra question. 5 and 6 refer to the following information. Let's zoom back out a little bit. Okay. Scatter plot above shows the number of hits and the number of times at bat each of the 20 players on a Major League Baseball team. The line of best fit for the data is shown. So there's your line of best fit. On the x-axis, we have the number of times at bat, and the y, the number of hits. All right, so 5 and 6. What do you think? What's the relationship between number of times at bat and number of hits? Which one is true?
D.
As the number of times at bat increases, the number of hits increases. Okay. As the number of times at bat increases, so as we go, that means as we go up in the y direction, we go up in the x direction. Is that true? That's true. Yeah, that looks like it's true. As the number of times at bat increases, the number of hits increases. What about A? As the number of times at bat increases, the number of hits decreases. Is that true or false?
False.
False, yep. C, as the number of times at bat increases, so as the x-axis increases, the number of hits remains constant. Is that true or false?
False.
False. And then D, as the number of times at bat decreases, so as we go to the left on the x-axis, the number of hits decreases. Is that true or false?
False.
As the number of times at bat decreases, going to the left here, the number of hits decreases. The number of hits decreases. That's true. That means
This
as you,
says increases.
oh, my bad. No, yeah, you're right. Yeah, you're right. False. Yep. If this was decreases, then we would. So as one variable increases, the other increases. What does that mean? What is that? What's a word for that? You know what word that word? All right, let me say that again. As we go up in the as we increase in the x-axis, we increase in the y-axis, right? That's what basically B is saying, right? What does that mean? What's a word for that? There's a mathematical or statistical word that describes that. Do you know what it is? There so we have a couple cases, right? Okay, so we have x and y, right? Oh no, let me switch this. Let me do it like this. Let me write y first. Y and x, right? There's our two variables. So as one increases, the other increases, right? As one decreases, the other decreases. What is this? Okay, so we have those two cases, right? What's a word that describes this situation right here? They're related, right? But what's another word for that? Have you ever heard of this word? Proportional. Proportional. What does that mean? Proportional.
They're the same.
They're not the same. Like let's, for example, if this one increased by a factor of 3, and this one increased by a factor of 3, that would be the same. But if it's proportional, say y would increase by a factor of 3, but x would increase by a factor of 5, or 7, or 8, or half, or 2. Those numbers won't be the same, but they're proportional, right? So they wouldn't be the same, but when we say proportional, as one increases, the other increases by a certain amount, but not the same amount. So all right, that's one instance, right? And then same thing in the opposite direction. As one decreases, say by a factor of 5, the other decreases by a factor of, say, 3 or 7 or 10 or, something like that. Some number that's not 5. Okay, so that's proportional. Now, let me ask you this now. That's what proportional means, right? Okay, so now let's have set up our equations again, a little chart. What does this one mean? As one increases, the other decreases. As this one decreases, this one increases. What's a word for that? Proportional is this case. What's a word for these two cases?
Um,
Starts with
this
I. Basically, they act in opposites of each other. This case, they act in the same direction of each other, right? This case, they act in the opposite direction. What's a word for that? Starts with an I. They are inversely proportional. Inversely, I don't know how to spell inversely. They're inverses of each other. What does inverse mean?
opposite.
Opposite, exactly. So in this case right here, they're inversely proportional. Inversely proportional. This one they're um, they're proportionally related. So inverse, the opposite, and proportional is like kind of like the same. Okay. Just remember what inverse means. Opposite. All right. Let me actually now in terms of the graph, is this graph going up to the right? Is that proportional? Or is that inverse?
Proportional.
Yeah. So the inverse graph would look something like the exact opposite. As one increases, the other. As one increases, as the y increases, the x decreases. As the x decreases, the y increases. Yep. Opposite, basically. Okay, so that's 5. Now, what about 6? For the player with 450 times at bat, the actual number of hits the player had is approximately how many fewer than the number of hits predicted by the line of best fit? How are we going to do that one? Do you know what that means? Or what they're asking? All right, so for the player with 450 times at bat, which is right here, right? There's your 450. And there's your, what does that look like? 125. For the player with 450 times at bat, the actual number of hits the player had is approximately how many fewer than the number of hits predicted by the line of best fit? Okay. Okay, so see this number right here? See 450 is this right here and this. So what number is this right here? What number is this one right here? And then we know this is 125, but what's this number right here? What's the number exactly between 100 and 125? This is about like, we'll say 112 or 113, right? That's exactly between these two numbers, right? So for the player with 450 times at bat, the actual number of hits the player had, which is this number right here, 112. Sorry, 450 at bats is 112 hits. The actual number of hits the player had is approximately how many fewer than the number of hits predicted by the line of best fit. So basically, what's the difference between these two numbers? About 13, 12 or 13? All right, so we'll go with this one. Okay. About 10. Get that question?
Yeah.
450 at bats is there's your 450. Actual number of hits a player had is approximately how many fewer than the number of hits predicted by line of best fit. Line of best fit would be this one right here. Actually, we're using this number, not the 125. It's actually a little bit higher than 125. So 125, say minus. Well, actually, this is like 126 or 127, right? So minus this number, 112 or 113. Okay. 6. All right, 7. At an advertisement.
An advertisement states that the printing rate of a certain printer is 400 characters per second. According to the convention that one word consists of 5 characters, what would be the advertised printing rate in words per minute?
All right, so this one's like that set up your ratio. It was like the one we did a few minutes ago. Advertisement states that the printing rate of a certain printer is 400 characters per second. According to the convention that one word consists of 5 characters, what would be the advertised printing rate in words per minute? So 400 per second. Now that's 400 characters, right? Over 1 second. We might have to do a conversion here. Yeah, 400C over 1 second. Yep. Okay, so now what's the next ratio?
Um,
According to the convention, that one word consists of 5 characters. So see how we have characters on the top here? We need to keep characters on. Actually, we're gonna keep characters. We want characters, so we're gonna multiply this by another ratio, right? So see how we have characters on top here? We want characters on the bottom here, so they'll cancel. So if we put C there, what's here and what's here? According to this, according to this right here. Yep. And then what's on top? 5 characters is one word. Just put one word or one W. Okay. All right. So now, okay. So when we multiply, what we're trying to get is characters per words per minute. Words per no, we don't want characters. We want words per minute right here. What we're trying to end up with is words on top and minutes on the bottom, right? According to this right here, words per minute, right? So we want words per minute. So that's what we're trying to get. So the C's will cancel, the characters will cancel. What can we multiply next to get to this? We want words on top, so words will be on top. We want okay. So now look at this ratio right here, or the bottom right here. This is 1 second, right? What? So we want the seconds to cancel, right? We want seconds to cancel, and we want minutes on the bottom here. So the seconds will cancel there. So we'll be left with words per minute. Okay. So let me ask you this. Oops. How many seconds in 1 minute?
60.
How many seconds in one? Yep. 60 seconds in 1 minute, right? Now, the C's will cancel. Those two C's will cancel. The S's will cancel. So look what we have left over. W over M, which is what we want. W over M. So how are we going to, what does this work out to be? Or just multiply it out. 400 times 60 is 400 times 60 divided by 5. Or you could just cancel it, right? This is 1. This is 12. What's 12 times 400?
4,800.
Yeah, there you go, right? 4,800. And what would the units be? What's not canceled out? W, words per
Words per
minute.
minute.
Yeah. So this is kind of like two things in one here. We're setting up ratios and we're setting up conversions, right? They tell us 400 characters. This is one conversion here, another conversion, and another conversion. So we want to be left over with the right units at the end, words per minute, right? Words per minute. Okay. And then it's just a matter of multiplying or dividing. Okay. Conversion type of question. All right, 8. All right, try 8. Table above shows.
The table above shows the yearly salary in dollars of an employee at a company. Which of the following best describes the type of model that fits the data in the table?
Yep. Linear increasing by approximately that. Linear increasing by approximately that. Exponential, exponential. Do you know the difference between linear and exponential?
It-
Yeah. Yeah.
Linear is a straight line, and then exponential is just
You know what that one looks like? So here we have two graphs, right? Linear is this, right? Exponential is like this. Actually, I didn't draw this one too good. Linear is like straight, like slowly, slowly up to the right. But exponential start off in the same spot, but it's like way more growth, quicker growth. Okay. So which one?
A.
Linear, increasing by approximately that. It is linear, right? Look at the difference here, 38,000 here and 42,000 here. So it's not increasing by a lot. So it's increasing slower, which is linear. And then what's the difference between these two numbers? These two numbers, these two numbers, these two numbers. Is it this much?
Yeah.
Let's try this one. What's 42,769 minus this one? 42,769 minus 41,524. Is it about this or is it about this?
It's it's B, but
It's B, the 1245. Subtract these two, subtract these two, subtract these two, subtract these two. Would it be this number approximately, or is it this number approximately? This one, this one minus this one is that exactly. What's this? What's 40,314 minus this one? What is 4314 minus this one here? 39. 140. What is that? 4. 11 minus 4 is 7. 2 minus 1 is 1. 1. 1174. So look, okay, so between this one and this one, it's about A. What about 41,524 minus 43,14? What is that?
1210.
1210. Okay, and then 42 minus the 41. 3 minus 4. How much?
That was 1245.
Okay, so it's increasing. All right, let's check. I'm guessing A. I'm thinking A, but let's check. Let's see if we can find the answer on that one. Yeah, the answer. What is that? 4. 4A. The answer is here, 4A. Directions. Reading test, math, no calculator, math. What is this? 4DM? Does that make sense? Is that the right one though? 4D? Exponential? I don't think it's exponential. What do we say? What's these? Exponential, increasing by approximately 9% every year. Is this a 9% increase between here and here, here and here, here and here, here and here? How do we check that? Do you know how to check that? If we take this number right here, 38,000, multiply that by 1.09. What number do you get? Is it 39,140?
41,420.
40. Okay, so it's not 9%. Try take the 38,000 and multiply by 1.03. What number do you get? Is it 39,140? That would be this one.
Yes.
It is? And then take the 39,140, multiply that by 1.03. See if it's the 43,140.
Yes.
And then do the same thing again to see if it's 41,524.
Yeah.
Okay, and then one more time. Take that and multiply by 1.03 to see if it's 42,769.
Yes.
Okay, so then yeah, I was wrong. It's exponential. Okay, so yeah, all right. So then I was wrong on that one. It's exponential C. So 8C. Okay, 8. That was 8. All right, so they give you this formula or this equation right here. Which of the following is equivalent to the expression above? So how do we do this one?
You.
Just collect like terms there, right?
Yeah. And I like chips.
X squared y. Now you've got a double negative here, right? So it turns out to be plus. So what would it be? What would this one turn out to be? The x squared y. 1 plus 1, right? So it's either this one or this one. Now just go on to the y squareds. Negative 3y squared minus minus, right? So that's plus. 3 plus 3 is 6y squared. So it looks like it's this one. Now check the xy squared. 5 minus 3. Is that 8?
Maybe 2. XY
Yeah.
squared.
Yeah, that's what I was thinking. All right, so let's see here. Okay, so this one, right? This one goes with this one, right? Negative 3y squared goes with this one. Plus 5y squared and 3y squared. So this one and this one. Now, the only thing is to watch the signs, right? 1 minus minus is 2. 1 minus minus 1 is 2. So 2x squared y. Let's do this one next. The xy squared. 5 minus what? 3 here. 5 minus 3 is 2, right? So plus 2xy squared, and then the y squared. Negative 3y squared minus 3. That's plus, right? So this will be plus what? 6y squared. that right?
Wouldn't it cancel out?
Which one?
If the 3y squared? Because this one's negative, but then
Yeah.
this one would be positive.
Yes, that's right. Minus minus would be positive, right? So there is no y squared term then, right? So it's just this. So which one is that? That's A, right? A.
Yes.
Yep. Eraser. That one you just got to remember the distributive law, right? The negative sign. All right, 9. That was 9. 10. All right, how are we going to do 10? Which of the following describes the solution to that equation?
Distribute the 7 first.
Okay, we could do that. Yep. And then, okay, so do it on the side here or underneath here. We can distribute the 7 on the right side. So 7 times half is 3.5. So 7 over 2 minus 7 over 2x minus 49 would be the right side. Can we clean this up? Can we simplify this? What's 4 minus half? What's this right here? Simplify that and then distribute the 7 on the right hand side. You know what I mean? What's 4 minus half? 3.5, right? And what's 3.5 as a fraction? What's 3.5 as an improper fraction?
7 over 2.
Yeah, so 7 over 2x minus 7 would be the left side. Yep, and then minus 7, yeah, and equals. So now distribute the 7 on the right hand side. 7 over 2x minus 49. Yep. Okay, so now, okay, if we solve for x there, what do we get? So just do it like this. Just collect all the x's on the left side. So 7 over 2x and then 7 over 2x, right? That's this one is this first one. So we're going to take this to the other side. So is it going to be minus here or plus here?
Minus.
Minus, right? And then this will be negative 49 plus 7 or minus 7?
7.
Plus 7. Now that'll cancel out, right? 3.5 minus 3.5, that's just 0x equals, what is this, negative 42. So what does x equal?
0. Or no solution.
Let me see here. If it's 0, that goes to 0, that goes to 0. So negative 7 on the left side equals, that goes to 0. 7, the right side will be what, negative 49? So those two do not equal, right? Those two do not equal. So it's not x equals 0. That'll go to 0. That'll go to 0. -7. That'll go to 0. 7 times -7 is okay. So it's not that one. 10 and a half. How do we check the 10 and a half? Same idea. Check the 10 and a half. See if left side equals right side. Infinite many solutions has no solutions. 10 and a half. So if x equals 0, all right, so check this one. Take the 10 and a half and plug it in there, and see if left side equals right side. What is 4 times 10 and a half?
42.
Yep. Yep. So this is so 42 is the first one. What's half times 10 and a half?
Um,
Half times
five
half
and a
time.
quarter.
Uh, so 5 1/4 is 5. Okay, we'll just write it like that. -7. We're gonna check. So we got the left side. What's the right side here? Half times 10 and a half is what again? 5
Five
1/4.
and a quarter.
5 1/4. Yeah, so 5 1/4. And then -49. So is the left side equal to right side here? Yes. Wait a second. 42 minus 47 is what? 42 minus 7 is 35, right?
Yeah.
So does left side equal right side there?
Yeah.
Uh, let's check if we did that right. 42 minus 5 1/4 minus 7 equals, if we put it in a half here, that's 5 1/4 minus 4. Oh, did we multiply? Yeah, sorry, we didn't multiply by 7 here. I forgot multiply by 7 here. What is 7 times half times 5 1/4? If we multiply those three things, what do we get? What's that times that? 7 1/2. 7 times half is 7/2 times, what's this one? This is what, 21/4? Can we cancel anything there? No. So this is 7. What is this? 147/8. So 147/8. Now check if this equals this. Does it work out?
Well,
No? It doesn't?
it does.
It does or doesn't?
Does not.
Does not? Okay, so if it's not A or B, then it has to be which one of these two?
D.
No solutions. Yeah. Yeah, I think it's D. No solutions. Yep. Okay. That was 10. 11. Okay, so the table. All right, so they give you a little table, the people, the months. All right, so which one? A, B, C, D. Monthly electricity bills. Based on the information in the table, which of these statements is true about the ranges and medians? How do you find range again?
The biggest number, and it's the smallest number.
Yeah, yep, the difference of those, yep. And how do you find median?
Add add all the numbers and divide by how many numbers there are.
Um,
Like the
that's
median. Oh,
that's that's
like you
mean.
like you write them out in number order and then like, try to find the one in the middle.
Yeah, right. Yeah, write it out in increasing order and then find the one in the middle. Yep. Okay, so what's the range for Joseph? What's the biggest number here?
193.
So Joseph and Samuel. Okay, so range equals what's the number?
193.12.
193. And what's the smallest?
145.30.
Okay, whatever that works out to be is your range. And then the median, what's the smallest? 145. 145.30 is the first one. What's the second smallest? 175.
175.
Third smallest?
180. 180.
180.33. Next one?
184.
184. And then the last one is 193, right? So what's the
Yeah.
median there? That one. Okay. What's this? Find the difference here. What's the 193.12 minus the 145? What is it?
47.82.
47.82.
Yeah.
All right, so there's your range and median for Joseph. Do the same thing for Samuel down here. And then we'll compare the two numbers. Based on which of these statements is true about the ranges and medians?
The range is 39.76.
All right, right here. And then write the median. Okay, so and now what's the median? Smallest is 149. Next one is 176, 181, 185, 188. Which one's in the middle there? What's the third biggest number?
185.
Yeah, 185.66. So write that down and then we'll look at it. 185.66. Smallest, second smallest. Okay, so this will be the small. That's first smallest. Second smallest is that one. Third smallest. Oh, no, I think it's the 181, right?
Yeah, it's 181.
181. So this one. So that's your median, right? 181. 27. Okay, now we have all the four numbers, right? That number, that number, that number, that number. Okay, so now Now, which one? A, B, C, D.
D.
The range of Joseph's bills is greater than the range of Samuel's bills. That's true. While the median of Joseph's bill is less than the median of Samuel's. That's true also. What about A, B, C? Both the range and median of Joseph's are the less than the range. Both the range and median of Joseph's bills are less than Samuel. No. Both the range and median of Joseph's bills are greater than. No. The range of Joseph's bill, which is what, 47, is less than the range of Samuel's bill, which is 39. While the median of Joseph's bill is greater than, no, yeah, it's D. Yep. Okay, good. All right, that's good. You remember mean and mode? What's mean and mode?
Mean is the average.
And how do you
And
calculate the average?
add all the numbers and divide by how many numbers there are.
Yep. And how do you find mode?
The the amount of times each number like occurs in the list.
Yeah. So if you have it in increasing order, the number that occurs the most often. Right. Okay, that's 11. 12. Cars in a service on a railroad, in service less than 10 years, in service more than 10 years, single level, double decker. The table above presents information about the 810 train cars in service on a railroad. Approximately what percent of the train cars in service are double decker cars that have been in service for less than 10 years? What's the ratio? So there's our fraction. What's the number on top? What's the number on the bottom?
So
Over 16 divided by what? Yep. And what's that percentage? 16 divided by 810 is about 2%. Yeah, A. Yep. Now, when you add up those, yeah, that's right. So A, right? So when you add up these four numbers, what number do you expect to get?
110.
Yeah, exactly. Those four numbers added together gives you the 810. Yep. All right. That's 12. 13. A moving company uses plastic wrap to bundle groups of boxes together. If a portion of plastic wrap that measures 900 inches in length is used to bundle each group of boxes, how many groups of boxes can be bundled using 1,500 feet of the same type? Or how are we going to do this one? Movie company uses plastic wrap to bundle groups of boxes together. If a portion of plastic wrap measures 900 inches in length, so there's your 900, there's your wrap, right? This is 900 inches. in length is used to bundle each group of boxes. How many groups of boxes can be bundled using 1,500 feet of the same type of plastic wrap? Okay, so we have inches and feet. How many groups of boxes can be bundled using 1,500 feet of the same type? So how do we do this one? This is plastic wrap to bundle groups, okay. If a portion of plastic wrap measures 900 inches in length is used to bundle each group of boxes, how many groups of boxes can be bundled using 1,500 feet? Okay, so we have to do a little conversion here, right? So how do we do this? How do we do this?
Can convert 1,500 feet to inches.
Yep, okay, so 1,500 feet is X inches, right? X inches. Now we know that, do you know the conversion of inches and feet off the top of your head?
12 inches and a foot.
Yep. Okay. So 12 inches is 1 foot. Okay. So cross multiply here. Okay. So once we do that, then what? What's 1,500 times 12?
18,000.
18,000. Okay. Now we have the 18,000. Now what do we, so this is what, inches, right? This is inches. Now what do we do?
Divide that by 900.
Yes, which should be the 20, right? That should be 20. 18,000 divided by 900. Just cancel two zeros, right? Cancel two zeros there, cancel two zeros there. It's the same thing as 180 divided by 9, which is 20, right? 20. Yep. Good. Any questions on that stuff? You said your test is in March, right?
Yes.
All right. Yeah, the idea is just to practice a few questions every day, right? On your own.
Yeah.
All right. 14, 15. How many left? Oh, there's a bunch left. All right. Yeah, just practice on your own a little bit every day. Just go to Google and just search PSAT practice test or SAT practice test. They're all the similar questions, right? GMAT, GRE, PSAT, SAT. They're all the similar questions, right? So just go on Google and pull up one of these practice tests and just practice on a few questions on your own every day. Okay. What day is it? Today's the 17th, right?
Yeah.
I'm gonna text your mom and see what day you want us to meet again. Maybe take a break next week. Maybe on the 31st or in January 7th, maybe. All right, I'm gonna text your mom and find out when we're gonna meet again. Okay.
Okay.
But in the meantime, just keep putting the practice in. That's all. You'll be okay. All right, Allee, I'll talk to you later.
Bye.
Okay, bye.